Hi everybody and welcome back to Absolution Water. My name is Julio Reyes and let's do another math problem. The question reads like this. A well containing 30 parts per million chromium is pumping into a distribution system. The well is blended with a treated water surface source which has a chromium concentration of 1 milligram per liter. If your target is 3 parts per million chromium between the two sources, what should your well and source water flow be in gallons per minute if your total flow between the two sources is 5,000 gallons per minute? I read a little bit more into that for you. Let's just start by recognizing that I expressed chromium in milligrams per liter here and in parts per million here because I wanted you to know that in your exams, they could be expressed in either way. So just know that 1 milligram per liter is exactly identical to 1 part per million. So they're used interchangeably, so do not be confused with that. Just on a side note, too, I wrote the abbreviation for chromium right here, and I concentration just to save room. So anyway, let's go forward. What we see here is we see two different sources, a well source and a surface water source. And the well source has a concentration of 30 parts per million, and the surface water source has a concentration of 1. So we recognize two separate sources with their own respective concentrations, and we want to target 3 parts per million. So when you recognize two sources with two different concentrations and a targeted or a desired outcome for a concentration, that is definitely going to be a blending formula. And so it's not even necessarily a formula, it's just a process, a procedure in how to set things up. And so the template is like this. You're going to get your high concentration. You're going to write it here. Then you're going to get your low concentration, and you're going to write it there. You're going to get your targeted concentration. And I like to set it up like this. So let's start with that. Our high concentration is 30, and our low concentration is 1, and our targeted concentration is 3. Those are all parts per million or milligrams per liter. I'm just going to circle them. And so then the next step is we're going to do some subtraction. And so let's start with this high concentration here. So this high concentration minus the targeted concentration is 27. What about on this side here? I could see that our low concentration is 1 and our targeted is 3, so it should be a negative number. But we won't write the negative number here. We're just going to write whatever the answer is in a positive expression. So 1 minus 3 is actually a minus 2, but we're just going to write 2. If you're familiar with the term absolute value, it's nothing more than the absolute value. So I'm going to write 2 here. And then the next thing that I'm going to do is I'm going to write it as a fraction on both of them. And what goes on the bottom is the difference between the high concentration and the low concentration. So our high concentration is 30, and our low concentration is 1. And so therefore, the difference between the two is 29. That goes on the bottom here. And the last thing we do is we multiply both fractions by your combined flow. Because we have two sources, so they're going to split the difference between the two. And they're both going to total 5,000 gallons per minute. So the flow here, the combined flow, is 5,000. Same for the bottom. And all we have to do now is simplify the top and the bottom. So on the top, you can do it a couple of different ways. You can say 2 times 5,000 divided by 29, or you can say 2 divided by 29 times 5,000. Because they're all related by multiplication, it's all going to work. So I get 344.83 GPM on the top. And on the bottom, I get 4655.17 GPM. Now, one thing that I like to do is, I've had operators kind of get confused, is they will see that high concentration and they follow it through to the targeted, and they will call the high concentration answer is 4655. That's not true. So what I like to do to keep us in the same direction is I'll just draw some arrows. So that way this arrow is telling us that the high concentration answer is going to be on the top and the low concentration answer is going to be on the bottom. That's why I like to write those arrows there. Okay, and so therefore, the high concentration, which is going to be our groundwater, is going to be 344.83 gallons per minute. And the low concentration, which is our surface water source, is 4655.17 gallons per minute. So let's back up a little bit and just look at it from a practical point of view. You have a source which is really not very good water quality. You don't want to put as much into it. So sometimes when we're really grinding away at our math problems, we need to just take a minute and step back and make sure that it's practical. Because sometimes we'll blast through a math problem and realize, wow, I was doing it so quickly that I didn't even take the time to zoom out and see if my answer makes sense. So whenever you do these blendings, it's a good opportunity to step back and say, yeah, that makes a lot of sense. My poor water quality, which is the 30 parts per million, has a very low flow of 344 gallons. And the high quality water has a very high flow. So that makes a lot of sense. Lastly, what we could do here is I like to check our work. And the way I could check the work here, we can't always check the work, but we could check the work here is this flow plus this flow should equal your total flow. Now, if you don't round at the right place, you might get an approximate number. Like if you add the two, you might get something like 4,999.6 or something like that. Just know you just did not round at the right place and that your answer is very, very close. Therefore, your multiple choice problems, they're not going to be that close to each other, so don't worry about choosing one that's kind of close. They're typically on the exams, they're off by decimal, or they'll give you an answer where a common mistake occurs and provide that as one of the answers. And so when you check your work, if you don't get exactly 5,000 gallons per minute, as long as it's very, very close, then you should be fine. I hope you found that helpful. For more videos like this and other resources, visit our website at www.absolutionwater.com, the answer for water professionals.